Hello, welcome back. It's been a long time since I recorded this video. I have some health issues. I got piles, so let's continue and let's bypass the AMSI by hooking the LdrLoadDll function. So it belongs to NITRO DLL, and you can see the path to the file and the flags, module file name, and the module handle. So the return value is the handle to the DLL that is being loaded, and the third parameter is the module file name, where we can check for the DLL name for which DLL it is being loaded. So in the previous video we have set the hardware breakpoint at the AMSI scan buffer function address. Now we can change this to NTDLL and LdrLoadDll. Now this function is address is being passed into the enter debugging loop. So before that we will be setting the hardware breakpoint for the first time. So this is the code where we have left in the previous videos. This we will be waiting for the debug event, and if it is occur we will continue. So let's check here. Let's rename this to NTDLL. So first what we are going to do is we are going to print the DLL names that this function is loading. If the function address is the exception address, then we are at this stage where this function is loading. So RCX, RDX and R8 register. So R8 register contains the pointer to the Unicode string structure. So the Unicode string structure contains the buffer, pointer and the length and maximum length. So what we are going to do is we are going to parse the content at this address as a Unicode string. So we already got the context. The third parameter is R8 register. So parse structure from memory. So we are going to copy the context.r8, self dot process information dot process handle, context.r8, and we are going to parse this as Unicode string. Let UC is equals to, or you can say US, Unicode string, and now in this Unicode string you have the buffer length and maximum length. We can say read Unicode string from memory us.buffer. Let DLL name. So print, we can say DLL name, DLL being loaded is the DLL name. And we can say DLL exception handled and false, because we do not want to clear hardware breakpoint now. Okay, I think all the loaded DLLs have been loaded already. So what we can do is we can create a new PowerShell process. We can create a new PowerShell child process, and immediately we can hook into that child process. So I have copied the code of creating the process using the create process function. So here we will be creating the new process. And we can say pi dot process id. So here we are creating a new PowerShell process, and we are attaching to that process and setting the hardware breakpoint at the LdrLoadDll function address. So let's go and run this. So I think we are going to say debug continue. And we should also clear the hardware breakpoint. Sorry, my bad. So let's write another function. Let's copy this and say clear hardware breakpoint function custom. So this is for our LdrLoadDll address. So what we are going to do is, so in the previous video we have set the length of the AMSI scan buffer to parameter to 1, so that we will get the clean result. Now we are just clearing the hardware breakpoint. So let's run this again. So it exited. So we can see the DLL being loaded is kernel32.dll. So clear hardware breakpoint custom. Sorry. So we have created the PowerShell process. We can also see the DLLs being loaded. And we can see one DLL here. So sorry, my bad. Let's comment out this code. So let's create the we already written the create new process, so let's use that one because it will create in the debug only this process mode. So we can see all the DLL names that are being loaded. So previously when I tried to create the new process and attach it to it, it worked, but now it's not working. So we can see all the DLL names. So we are getting a latency because of this sleep from the 1 second. So if you do not sleep for 1 second, you will get some access violation error. So okay, it's actually working. I thought it's not working. So it took a lot of time to get this screen, just 1 minute I guess. So sorry, my bad. So previously I did not face this issue. So let's debug that later. Now we are printing the DLL names. So we are just printing the DLL names here. What we are going to do is we are going to modify the first letter of amsi.dll to some random character. So what this does is the LdrLoadDll function tries to load the DLL with the file name it does not exist. So it will throw an error that amsi.dll was not found, and the amsi.dll will not get loaded. So let's do that. So let's copy this code snippet. So in the R8 register we have the pointer to the Unicode string structure and us.buffer. So let buffer is equals to So we are going to replace the first character of the amsi.dll name to the amsi.dll 120. So we can say 120 u8. So we are going to write the content of this buffer at write process memory, process handle, and then we are going to write at the us.buffer. Buffer.length, and then we are going to set the thread context as usual. We are just modifying the first character of the amsi.dll into some random character. So I think we are good to go. So after setting the thread context, after continuing, the function will raise an error and the amsi.dll will not load. So let's run this. It is going to take some. Let's run this again. Sorry, our bad. So what we are doing is we need to compare the DLL name to the amsi.dll, then only we need to clear the set the name. So we need to modify the first character. So if DLL name dot to lowercase is equals to amsi.dll, then only we are going to modify the first character. So let's copy this and paste here, and let's call this as clear hardware breakpoint original and remove this content. So we are just clearing the hardware breakpoint. We are not doing any modifications to any content in the registers. So if the DLL name is amsi.dll that is being loaded, then only we are going to modify. Otherwise we can call this original, not to modify the contents. So now we should see the output of invoke mimikatch. So we can see we have successfully bypassed the AMSI scan buffer function because the amsi.dll is not loaded yet. So let's also remove this. Let's remove this and see whether we can print or not. I have no idea why this is very slow. So 1 week back I have tested this and it's working very fast. So we are good to go. So now we have been blocked by antivirus because we have commented out our modification of the amsi.dll name. Now let's run this again. I also downloaded the process hacker to check the DLLs. So we can see the PowerShell process is being run as child from the Simple Debugger. So there is no amsi.dll. So that's all for the video. It took so long because PowerShell process took so long to load. I thought it's not loading. So previously I did not face this issue. So that's all for this video. We have set the hardware breakpoint at LdrLoadDll function and prevented the loading of amsi.dll. Eventually our content will be clean.